Hello everybody, I thought I'd do an update on this. It's now complete with 3 coils. Each coil has its own circuit like this, or like this. Now the only difference is I've now got 2 resistors in parallel and 2 diodes on the output in parallel, because that halves the voltage drop. Now like I say, I've been charging capacitors with it, because that's what I got it for. That's the voltage of it, look. These books. Like I say, on 12 volts, it will charge up this capacitor to 205 volts, and then it doesn't go any higher. I know that people are going to say that's the impedance, but that's alright. This is just version 1. I mean, on version 2, I'm going to make an extra 3 coils, which I'm going to have opposite to these coils. I'm not going to have 3 more circuits, I'm only going to have like 2 coils in series on each. Like I say, I'm charging these up for the coil gun I made. But like I say, people online who do these coil guns, they say they only get about 10% efficiency. I reckon it's because your microcircuit, you're trying to put the discharge the capacitor through, because you don't get a spark in it, do you? So if you don't have a spark, it can't be as much of a discharge. I'm going to turn it on and power this up, and then I'll discharge it. We see it stopping a bit anyway. See it like stop there, innit? If I turn the speed up a minute though, it literally starts dropping. So I'll turn it off a minute. And there you go, got this to spark it with. What's that on there? It's done most of it. Anyway, I'm going to take this off. What's enough about that? I'll put it on the LED instead. Like I said, I'll just turn it on. You see how fast it goes. I think it'll go faster when I get an extra 3 coils on it, even though it would be like double the ohms resistance. You can't really see what's going on there, really. That's probably as fast as it goes on 12 volt. So what happens if I turn up to 24 volt? It's soon to get faster. Because there's only 2 magnets on it, it's quite mad really, like with seafood, isn't it? That is light bright. Can you hear the re-switch? Let's turn it off. Still sort of goes, but this wire is too thick really to pick up energy off the magnet. It's 50mm, 0.50mm. It's quite smooth. But what I've got here is this shaft. I've got a drill bit the same size as that shaft, so I drilled over in that piece of wood there at the bottom that you can't really see. And then I hammered the shaft into it, so this shaft is actually quite stable in place. And I also done the same with this here, but I drilled out the holes a bit more to make it a bit looser. But when I do version 2, you know, I'm going to have 6 coils, but I'm also going to upgrade that to 4 magnets. So I should make it better. I'll show you that. Just a hole drilled in it, see? And that's my little toroid magnets. Yeah, there it is. It's not quite center though, but I would say it's quite even. But yeah, that's it for this video. I just can't bother to really make videos on it. But on my next video I'm going to talk about the coil again and why I've made it how I had and the different experiments I'm going to do. I've also made this. So I can fire through that. So like that way, isn't it? Or maybe that way. There's 3 there and there. Yeah, that way. I'm going to try it with different settings on the coil and then see how far it goes. Be mad if it goes all the way through there, doesn't it? But with that capacitor on 105 volts, it's about 22 joules of energy. And my pellet again, that's only 7 joules. And I'll test that on here, and then I'll test that on here using like both of them there. Really one of them is about the size of a 90mm bullet, and the other one's like the size of a 22 rifle bullet. But one should have twice the velocity of the other, and the other one should have twice the kinetic energy of the other. So we'll see how that differs firing into that. Alright, I'll see you later, bye.